In this video, we are going to find out what radians are. So the first thing you're going to do is you've already cut out your circle from earlier from the cardstock. What I want you to do is go ahead and read numbers 1 through 4 and go ahead and find out what the measure of angle theta will be. So now that I have my circle, it says to cut a piece of pipe cleaner. So I didn't have pipe cleaner, I just had this, but this will work because it's kind of stiff. This twist tie is folded to be the same length as the radius of my circle. So I've done that, I've done number 1. Number 2 says to curve the pipe cleaner along the circle and draw the central angle that intercepts or subtends the arc. So what that means is starting from here, I'm going to go ahead and curve it around. And when it curve it around, I can see, and I actually made a mark earlier, so you can see that I'm all wrapped up, so I did this a little ahead of time to make it a little bit easier. So I've curved it around, and there is my mark on there, meaning that from here to here is this length right here. So taking my straight edge, I'm going to go ahead and draw my other radius. So now what this means is that this here is my radius, and the length of this arc right here is the same length as this radius. It's just curved instead of straight. And I'm naming this angle theta. The next thing is it wants me to trace, so you're going to go ahead and do this now. I don't have patty paper because there's only one of me, but you're going to trace the angle with the patty paper and compare it with the angle with everybody in your group. Everybody in your group should have a slightly different circle, a different size circle, but I want you to go ahead and compare your angle with those in your group. After you've done that, now I want you to go ahead and measure your angle. Oops, that's upside down. That's not going to help me. Okay, so I'm going to go ahead and measure my angle. Did I do pretty well? I'm going to go ahead and zoom in a little bit. Okay, so since my zero, so my zero's on this side, so I'm going to read the bottom part. It's in between, it's a little bit more than halfway between 50 and 60. It looks to be about 57 degrees. So here, the measure of theta on here was 57 degrees. You also should have gotten something close to that. If you didn't, and you drew everything correctly, if your theta looks similar to this here, then that means that you probably used your protractor incorrectly. So get help with that. Now that means this theta here, this angle measure is equal to 57 degrees. Now that's measuring this angle and this arc measure in degrees. I can measure another way, which is in radians. And the way I'm going to do that is I'm going to measure the length of my radius. So taking my protractor, I'm going to measure in centimeters. Can you see that? Ooh, you cannot see that. That is bad. There we go. That is a really bad glare. Let's see, will this help? That helps a little bit. How about if I put it down a little bit? Okay, that looks a little bit. Okay, so here you can see I've measured it. Here's 0 and here's 5. So the measure of my radius is 5 centimeters. Yours might be different. So here is 5 centimeters. Now I can calculate the length of arc AB, but remember we already measured it. We measured it using this, so we know that this is the same measure as this over here. So the length of arc AB is 5 centimeters. Now, to find the measure of angle theta using radians, I'm going to create a ratio. It's the length of the arc divided by the length of the radius. Well, the length of my arc was 5 centimeters, and the length of my radius was 5 centimeters. When I divide those, I end up with 1. So the measure of this angle here in radians is 1 radian. Now, similar to degrees, radians describe angles and arc measures, not length. So let's go ahead and find equivalent degrees and radians. So we know that there are 360 degrees in an entire circle. And so now we're going to go ahead and find the number of radians in an entire circle. So I'm going to find so what I'm going to do is I'm going to say that my radius is 1, and I'm going to find the length of the arc in the circle with radius 1. Remember how we do this is we use the angle divided by 360 and then times the circumference. So times 2 times pi times r. I'm going to leave my answer in terms of pi, which means I'm going to multiply everything in my calculator except for the pi. So the length of the arc in the circle with a radius of 1, my theta is 360, so this would be 360 divided by 360 times 2 times pi times 1. And in my calculator, that turns out to be 360 divided by 360 times 2 times 1. Notice I left out the pi. So that gives me 2. So I end up having 2 pi. Now to find out what this is in radians, remember that radians is the length of the arc, which we just found, divided by our radius, which we said is 1. So that's going to be 2 pi divided by 1, which gives me 2 pi. Now for 180 degrees, this is going to be 180 over 360 times 2 times pi times 1. When I put everything in the calculator except for pi, this just ends up giving me pi. And this is my arc length. To find this angle in radians, I'm going to do the length of the arc divided by the radius, which gives me pi. For 90 degrees, this is going to be 90 divided by 360 times 2 times pi times 1. This is where the alpha y equals will come in handy. So 90 over 360 times 2 times 1 ends up giving me 1/2. So this turns out to be 1/2 times pi, which I am going to rewrite as pi over 2. So for my measure in radians, this is going to be pi over 2 divided by 1, which is just equal to pi over 2. For 60 degrees, it's going to be 60 over 360 times 2 times pi times 1. (60 over 360 times 2 times 1) gives me 1/3. So this would be 1/3 times pi, which I'm going to rewrite as pi over 3. The ratio would be pi over 3 over 1, which would just be equal to pi over 3. For 45, this is going to be 45 over 360 times 2 times pi times 1, which will end up being 1/4 pi, which I will rewrite as pi over 4. So in radians, it'll be pi over 4 divided by 1, which is pi over 4 radians. Now notice I did not write any units here. I don't have to because they've canceled out with the ratio. But I can go ahead and write in radians for some clarity, but I don't have to. And then finally for 30, this is going to be 30 over 360 times 2 times pi times 1, which is going to be 1/6 pi. So this, which is the same thing as pi over 6. So pi over 6 over 1 is just pi over 6 radians. So these are the angle measures and the arc measures in degrees, and these would be the equivalent arc measures and angles in radians. So what we know from here is that the total number of radians in a circle is 2 pi. If I have a semicircle as half a circle, that is going to be pi. And then after that, it's going to end up being some fraction of pi. Going on to the back side, if the radian measure of a central angle can be found using this ratio, so the length of the arc divided by the length of the radius, how can I find the length of an arc using the central angle and the length of the radius? So basically what they're asking for is how can I find the length of the arc? So how can I find the number on top? I'm going to simplify this a little bit. I'm going to call length of the arc, I'm going to make that a cursive L, and I'm going to make the length of the radius R. And the central angle I'm going to call theta. So according to this, if I want to find theta in radians, it's going to be the length of the arc divided by the radius. If I want to find the length of the arc, that means I'm going to solve for this. It's being divided by the radius. The opposite of dividing by the radius is multiplying by the radius on both sides. This cancels out, leaving the length by itself, which is equal to the radius times theta. So basically what I can do is I can multiply the radius times the central angle to find the length of the arc. Now, next question says, how would I find the radian measure of the arc using the central angle? So talking about measure here, we're not talking about how long it is, but we're talking about the measure of the angle. Well, remember that the arc measure is equal to the central angle measure. So that means my original ratio would help me with that. So to find the arc measure, which would be theta, it would be the length of the arc divided by the radius of the circle. Find the radian measures of the central angles and the intercepted arcs below. So I'm asked to find the central angle ACB and also the measure of arc AB. Remember, these are the same. This is the central angle and this is the arc measure, that they're the same. So I can find both of them using the length divided by the radius. So the length of my arc is 5. The radius is 7.5 centimeters. And that's going to be the same for both of these. I'm going to go ahead and do alpha y equals for this one. So 5 divided by 7.5 gives me, would give me 2/3 radian. So this would be 2/3 or 2/3 radians. For the second one, I'm going to use the same. I know the arc length and I know the radius measure. So it's going to be the arc length divided by the radius, which is going to be 3 divided by 2. And these are in inches. So this turns out to be 1.5. Remember, the arc measure is the same as the central angle measure. So this is also going to be 1.5 radians. In number 9, we are given 2 circles. We're told that the measure of arc LM is 9. Remember, we said we don't have, so what this means 9 radians, even though it doesn't say so. It means, so the measure of LM is 9 radians, and I want to find each of these. Remember, the angle measures are the same as the arc measures. The central angle measures are, at least. So that means if arc LM is 9 radians, then LCM, angle LCM, is also going to be 9 radians. ACD is actually just the same angle as LCM, so this is also going to be 9 radians. And the measure of arc AD is also going to be 9 radians. Now remember, these are radians, not lengths. So the length of AD and the length of arc LM, those will be different, but their measures are going to be the same because those measures are the same as the central angle. Okay, so for number 10, it says how many radians are in a circle. Remember that was 2 pi. And if you don't remember how we figured that out, we have the table here. So this is a full circle. And this is a semicircle. And another way to remember this, so radians in a circle, remember all the way around a circle is the circumference, and then divided by the radius. So this would be 2 pi r divided by r. The r's cancel, leaving us with 2 pi. How many radians are in a half circle or a semicircle? Well, that's going to be half of the full circle. So 2 pi divided by 2 is just going to be pi radians. A radian is a ratio of the arc length to the radius length. For D, 2 degrees is the same thing as 2 radians. That is false. And remember, and one way to think about this is to remember what the total is. With degrees, this is going to be out of a total of 360. For the radians, this is going to be out of a total of 2 pi, which is about the same as 6.28. So 2 out of 360 is not the same thing as 2 out of 6. It's much, much different. So a radian is a lot larger than a degree is. For E, 2 pi radians is the same thing as 2 radians. Again, this is false because 2 pi is about the same thing as 6.28, and 2 radians is just 2. Those numbers are not the same, so this is false. And for F, the bigger the circle, the bigger the radian measure. that is false, and that is what this problem here said. Remember, the radian measure is the same as the central angle. So the radian measures are going to be the same because it's going to match the central angle. The lengths will be different, but the measures will not.